I asked you for your thoughts on precession. Do you believe in it? Why or why not? This is what I heard in response. Just as a reminder, precession is the claim that the Earth wobbles while it spins, causing the North Pole to gradually shift position in one big circle. First, we'll hear from the Facebook group 2018 Flat Earth.
I don't have any memes on the precession specifically. The claim is that one full rotation takes 26,000 years to complete a 360 degrees wobble, which is 72 years per degree and therefore basically impossible for anyone to actually observe any supposed precession in a single lifetime. I'll believe a wobble of the firmament when I observe it myself. Until then, I don't buy it.
Nope. Don't believe in precession because we aren't even on a planet and our Earth doesn't move, the stellosphere moves. We are in a construct, a simulated reality.
I'm not quite on board with you when it comes to the simulated reality part, but I'm totally on board with you concerning the flat stationary Earth, with the exception of earthquakes and things of that nature. Next is the Council of Kyle.
Kyle Adams. Man, I forgot about you, dude. You are the nicer, less entertaining Flat Earth Kyle. Although I've been looking at some of your videos today. You've gotten better at being entertaining. Nice job. I still miss Stilson, though. Man, that guy was the best. Love you, Stilts. Miss you, buddy. Think you're awesome. We'll always love you. You're just the best one. Let's answer your question a little bit honestly there, Mr. Adams, shall we? So I'm not into astronomy. I'm just not that into it. Not into astronomy, not into astrology. They're not my favorite subjects. I understand a little bit about them. Enough to show my kids how to use a telescope, that kind of thing. So the precession of the equinoxes is not that difficult of a concept. So the Earth rotates on its axis and it wobbles a little bit. Like most rotating bodies, they wobble. It wobbles a little bit. Mainly because of the gravity, I know how y'all feel about those gravities in your side of the world, of the Earth, the Moon, and the Sun all interacting with it causes it to not rotate completely straight. It does a little bit of this. It's just when it does this, it does it very slowly. It's like every 27,000 years it completes a full rotation. This was discovered 3,000 years ago? No. Yeah, 3,000 years ago, I think by Ptolemy. I can't remember. I looked this up earlier today. But essentially because when looking at old star charts, because we've had star charts for ever, he noticed that the stars were in a slightly different position because every 100 years or so, the stars move by about a degree because of that rotational shift, right? Precession of the equinoxes. And it's a pretty easy thing to calculate once you get it figured out. Once you look at the original star position and the new star position, you can calculate why that is in an incorrect position on the same day, why they didn't stay in the same place on the same day 100 years later. You can figure out what the actual rotation of the Earth is. It's fun because you're kind of adding a rotation onto the rotation, so you have to do 2 calculations to make that work, but you can do it. I shared a video with you on how to do it, and I'm going to share the same video in the comments here because I know that it comes from YouTube. And you asked me an interesting question. You said, have I ever calculated that myself? Well, no, I haven't. I also really like looking at data about the bottom of the ocean, and I have never launched a sonar wave to the bottom of the ocean to figure out the shape and size and depth of those parts. But I still enjoy looking at that data. I've never fired a laser out into the horizon to measure the distance between that laser and the horizon to determine whether or not the Earth is round. I've seen other people do it. I've seen those experiments done before. And while I have never actually measured the precession of the equinoxes myself, I have seen in old star charts, of which there are hundreds of images up on the internet, because guess what? We've been measuring the position of stars, to the same degree that we do in modernity, that's the word, since the 1600s. right? Even before that, we were measuring them within a very high degree of accuracy. And even star charts from like 3,000 years ago are within a degree of accuracy that is very close to what we do today. So we know where their stars were back then, and we know where they are now, and we can measure that precession and that change over time. I know it's not the same as looking at a shiny rock in a hat to translate a language that never existed. But I'd say it's a pretty inaccurate way to go about things, wouldn't you? Love you, buddy. Nice day, Comey.
Hi folks, Astronomy Live here. A couple weeks ago, I drove out to a remote location on a road that runs due north and south. I set up my telescope and commanded it to point at 90 degrees positive declination, the north celestial pole. I then turned off the tracking and let it take an image for about 9.5 minutes. These images were taken with my Canon T5i and an Orion ST80 refractor riding piggyback on top of the main telescope. This was to recreate an image that I took 11 years ago, on January 10th, 2012, using that same Orion refractor and what I had at the time, a Canon XTI SLR, a very similar camera. Here is the EXIF data for one of the new images that I took on January 8th, 2023 at 5:11 Universal Time. Do note that in these images the camera is set to Universal Time, so that's the time shown in the EXIF data, and note that the exposure is the same, 572 seconds. Let's now compare the image taken in 2023 to the image that I first took in 2012. Here's the image that I took on January 10th, 2012. Note the very bright star in the upper left, that is Polaris. And now, as I crossfade it to the image taken in 2023, note that the trails have slightly changed. The star trail of Polaris is slightly shorter now, and the star trails on the right side of the image have lengthened. That's because the north celestial pole has moved due to precession, and it's now actually a little bit closer to Polaris than it was 11 years ago. Now, as I fade back and forth between them, you can see this motion quite clearly. We can use astrometry to measure this motion, and we can calculate the expected amount of precession over this time period and actually display where the north celestial pole was expected to be in these images and see if it lines up with these concentric circles of star trails.
Kyle Kraus, do you agree that the atmosphere is capable of refracting light and causing stars to shift where they appear to be? Do you agree that celestial refraction is a thing?
No reason to believe it. It's an observable phenomenon. Lower towards the horizon and closer to the equator, it's more extreme as that light is passing through more of the atmosphere.
That sounds like a yes. You agree that the atmosphere is capable of altering where stars appear to be. Now let's take a closer look at the footage you shared. You have two images taken 11 years apart with different cameras that show a very slight, nearly indistinguishable difference, and we don't even know if they were taken from the very same location. I see nothing to indicate that that very tiny change wasn't caused by different weather conditions. The other thing I notice about that observation is what is claimed to be Polaris doesn't appear to be centered in comparison to the other star trails. Compare that with this star trail footage. Something isn't quite adding up with the footage that you shared. Where is the center in your footage? Unlike your footage, there is no question here that this is the center of axial rotation.
The study of astronomy is a 5,000-year-old practice. At least that's how far back we have documentation of it. Babylonian and Egyptian star charts from the 9th dynasty still exist today and are comparable with observations and our predicted shifts in star positions for today.
Really? It'd be nice if you could actually show us something so we can have more to go on than just, trust me, bro.
Axial precession happens slowly over 41,000 years, but it's still a measurable change even within a year of relative positions of stars.
I think you mean precession, not procession. And 41,000 is a way different number than the 26,000 the book said. Nonetheless, my good friend Zach has a very interesting claim concerning Ptolemy and the name Stella Polaris.
Claudius Ptolemy, a Greek mathematician, is given credit for naming our pole star Stella Polaris in 169 AD. Stella Polaris in Latin literally translates to the pole star. It is important to know that Ptolemy had over 800 years of others' observations to build upon while naming 48 of the 88 constellations and the star Polaris. It is also important to share that this star already had a name to the Greeks, passed down by the Phoenicians. The Greeks wrote that the Phoenicians used this star for navigating at sea, and for this reason called it Phoenique. I have two major problems with the story we have been told. I merely have trouble believing one, yet the other is a glaring hole in the heliocentric model. We will start with the one less troubling for the heliocentric model and more a common sense question. Why would Ptolemy name any star, especially one that already had a name, the pole star, when he had over 800 years of knowledge to base his naming on? Since the first Greeks started observing the luminaries above the pole, the Earth Precession would have moved over 11 degrees during this time. Would anyone name a star that is known to precess over time the pole star? That is just one of my pet peeves that leads to an even bigger question. If the pole precesses and Polaris sits just off 90 degrees at our current time, where was it in the sky in 169 AD when Ptolemy named it? During this time, according to the heliocentric model, Polaris would have been over 27 degrees further back on the precession path, putting it far from the pole, with other stars much closer. So why did Ptolemy name a star that circumnavigated the pole with such a large arc around it as the pole star? In my opinion, the history does not match the model due to this glaring fact. I cannot believe the greatest astronomer of his time would give geographic names to stars he knew to move, and were nowhere close to the geographic location used in the name.
That is some really interesting stuff to think about. Thank you, Zach.
Enemy spotted.
What do you think about the precession of the Earth? As I have said before, I cannot personally prove the Earth is rotating or precessing, but because I accept well-attested third-party evidence, I provisionally accept that the Earth is rotating and precessing. What memes do you have on that topic? I do not rely on memes for my Earth-shape ideas. I rely on my own eyes and publicly available evidence, as we have discussed here a number of times.
Let's have a look at your two links. This and your "I rely on third-party evidence" is essentially saying, I know a guy who knows a guy, and I have faith in that guy. Except I don't think you actually know the author of this article. But thank you for sharing your thoughts on the matter. You're looking into it, and that's the important thing. I became a flat earther when I started to look into the textbooks and all these other things and found out that the whole globe foundation was a lot more shallow than I ever expected it to be. And the second link you provided is just repeating the same thing that the book said. It's just a different source. Your source being from Rochester University. My teacher said so, therefore it must be true! I'm sorry, that's just not good enough for me.
You do realize that Thuban, not Polaris, was the North Star during the Egyptian dynasties as the pyramids were being built? So there are records of the changing pole star recorded in human history?
Please expound on what makes you believe that. Darn! Now last time when we were talking about the spin of the Earth, Jaron shared a really interesting quote.
In his 1881 and 1887 experiments, Albert Michelson discovered the Earth was not moving around the Sun. As Michelson himself described the results of his own experiment, this conclusion directly contradicts the explanation, which presupposes that the Earth moves.
This quote has since been disputed.
So, yeah, I'm Ruhif, obviously. I didn't know much about Kyle until the other day. We'd chatted briefly on his channel and on his Miro board occasionally. I watched a video he put out yesterday about Earth bulge, so how the Earth, due to its rotation, sort of bulges out at the equator. So it's an ellipsoid rather than a perfect sphere. And this quote that's on the screen just now came up. It says, "This conclusion directly contradicts the explanation which presupposes that the Earth moves," by Albert Michelson of Michelson-Morely fame. And that is from a journal in 1881. And if you read that quote, you would think that Albert Michelson has concluded that the Earth doesn't move. But if you read the paper, there's quite a few paragraphs in there that obviously say that the Earth, or he believes at least that the Earth is moving. So, to coincide with the direction of Earth's motion, considering only the velocity of the Earth in its orbit, direction of the Earth's motion in its orbit, and again, the Earth's motion in its orbit. So these are all from the same source as that modified quote. You'll notice that there was a little ellipsis in the middle. But the paper itself, clearly shows that he doesn't believe that he, disproved Earth motion. So that's a misrepresentation of what Michelson actually thought. All right. So the actual quote is that his hypothesis was that the Earth moves through a stationary ether, and that's what he was testing. So you'll see the second paragraph there. So you've got the parts that are in the original quote mind quote. This conclusion directly contradicts the explanation of the phenomenon of aberration, which has hitherto been generally accepted and which presupposes that the Earth moves through the stationary ether. All right, so the quote mine was shortened to misrepresent Michelson's view of the Earth's orbit. So I want to give Kyle a chance to either retract the quote mine or double down, and then the audience can make up their mind on that, on his integrity.
In matters like this, I think it best to go directly to the source. The source in this case is the American Journal of Science in 1881. I found this copy on archive.org and have links provided on my debate board. This particular article starts at the top of page 120.
The undulatory theory of light assumes the existence of a medium called the ether, whose vibrations produce the phenomena of heat and light, and which is supposed to fill all space.
Undulatory theory. The undulatory theory of light, also known as the wave theory of light, is a scientific concept that describes light as a wave rather than a stream of particles.
Light is a wave.
So light definitely behaves like a wave. I'm just showing even just one example of light behaving like a wave. But if it is a wave, well, that means it needs to be, or if we use our classical logic, you would say, well, that means it's a disturbance traveling through a medium. But what is that medium? We have light coming from our sun. We call it sunlight. We have light coming. I keep wanting to make it actually our sun is white. We tend to draw it as a yellowish color, but that's just because of what happens as it goes through the atmosphere. So you have the sun, you have the earth. This is not drawn to scale, and somehow that light is able to reach us over 93 million miles. Over 93 million miles. What's it going through? Is it a disturbance traveling through a medium? Well, for a long time, people said, well, it must be. It has these wave-like properties. It seems to be traveling with the velocity, the speed of light. So there must be a medium that it is traveling through. And people theorized what this medium is. They called it the luminiferous ether.
According to Fresnel, the ether, which is enclosed in optical media, partakes of the motion of these media, to an extent depending on their indices of refraction. For air, this motion would be but a small fraction of that of the air itself and will be neglected. Assuming that the ether is at rest, the Earth moving through it, the time required for light to pass from one point to another on the Earth's surface would depend on the direction in which it travels.
Assuming the ether is at rest, the Earth moving through it, the time required for light to travel from one point to another on the Earth's surface would depend on the direction on which it travels. It, in this case, could be referring to the Earth, or it could be referring to light. But it definitely is not referring to the ether, which was described as stationary. Notice how the main idea in Michelson's opening premise isn't really about the ether. It is about the speed of the Earth and the speed of light. His premise is simply that the apparent speed of light should be different if it is going with the movement of the Earth or going against it. Next, Michelson starts to write a formula for his premise. Note how he doesn't list the ether here as an element being tested at all. Little v equals the speed of the Earth with respect to the ether. In this case, simply means with respect to a stationary position. The ether in this case might as well be a rock on the road with respect to the movement of a moving car and a moving train. Please notice how no part of this is designed to measure the speed of the ether, nor does any part of his purpose state that it's to prove the ether exists or not. It's all about the speed of the light and the speed of the Earth. If a car moves this way and a train moves this way, they should meet at a certain time, and that time should be different if the car is moving in a different direction. So he has his apparatus to test this, concerning the speed of light and the speed of the Earth. He holds his apparatus in every direction, and no matter what direction he held it, his results are pretty much the same. That is like saying no matter what way the car is facing, the train still meets it at the same time. And what is the big takeaway that so many get from this experiment? Oh, that must mean the rock doesn't exist! Or maybe since the Earth and the light were described as traveling through the stationary ether, it's like saying the road does not exist because the car and the train travel on the road. Come on, that's a load of crap! Now let's go take a look at the big quote in dispute, Michelson's conclusion. This is at the bottom of page 128. The interpretation of these results is that there is no displacement of the interference bands. The car and train appear to meet at the same time no matter which way the car drives. The result of the hypothesis of a stationary ether is thus shown to be incorrect, and the necessary conclusion follows that the hypothesis is erroneous. So there's an error with the assumption that the rock on the road is stationary. What did the rock have to do with anything? And exactly what led him to believe that? He doesn't say. But wait, there's more. Please also notice how at no point does he say, thus the ether does not exist. He continues on to say, this conclusion directly contradicts the explanation of the phenomenon of aberration, which has hitherto generally been accepted. And what is the phenomenon of aberration? It is directly referring to the motion of the Earth, both its spin and its orbit around the Sun. Therefore, we are justified in reading this. This conclusion directly contradicts the explanation of Earth movement, which has hitherto generally been accepted, and which presupposes that the Earth moves through the ether, the latter remaining at rest. The latter being the ether. So now he's making a lot more sense. No matter what way the car is facing, if that train meets the car every time at the same time, then that indicates that the car is not moving. That makes so much more sense. I therefore claim this quote is justified and rest my case on the matter. That should resolve this conflict. Now let's try and refocus in a little bit more on precession. My wife and I talked a little bit about this in our series, Modern Earth Science Destroyed. We were just reading from the textbook and talking about it.
Precession.
The illustration in figure 2-9 also shows that as the Earth completes its revolution of the Sun, its axis of rotation continuously points toward Polaris, the North Star. This has not always been the case, however. As the Earth rotates about its axis, the direction in which the axis points slowly changes in relation to the distant stars. This change results from a circular motion of the Earth's axis called precession. Precession is caused by forces acting on a spinning body, in this case, by the gravitational pull exerted on the rotating Earth by the Moon, the Sun, and the other planets. Precession causes the Earth's axis to move slowly in a circle, much like a top does as it spins on a table.
Comparing it to a top is interesting. However, the forces at work in the top are the top's momentum and the Earth's attracting forces pulling it downward.
And I can't ignore the friction between the table and the top that causes some of that wobble on the top. The globe doesn't have that.
On a heliocentric plane, I wonder how they claim all the other planets create this downward force without knocking the Earth out of line with the rest of the plane.
To compare that with what is taking place in a top, something just doesn't appear to be adding up. The Earth's axis, however, completes only one full circle every 26,000 years, so Polaris will continue to be our North Star for many years to come.
And there is another floating concept for us. Where is that number coming from?
It's a trust me bro statement. The textbook is making a claim and is doing nothing to back it up. Something else to really consider concerning precession is the lines of latitude on our maps are based on the angle at which you see Polaris in the sky. Even Neil Tyson will agree to this.
But I love it. I love it. Go ahead.
The North Star is 90 degrees up when you're at the North Pole, which is at a latitude of 90 degrees. That is not a coincidence, okay? If Santa Claus marches south, the North Star will get lower and lower and lower in the sky. Santa Claus gets to the equator, the North Star is on the horizon. The latitude of the equator is zero. The elevation of something on the horizon is 0. So, the elevation in degrees of the North Star above your horizon is your latitude on Earth.
Oh, because it follows all the way down.
It follows all the way down.
It follows all the way down. That's pretty interesting.
Yes, very interesting. And
That's
so
pretty
this was an important navigational tool.
That makes sense.
For everybody, right.
Now here's the thing. There are a ton of state boundary lines that are directly based on our lines of latitude. If you see long, smooth lines on a map, it's normally based off of either latitude, if it's going horizontally, or longitude, if it's going north to south. The Utah-Idaho border, for example, is based on 42 degrees latitude. And a large portion of the US-Canadian border is based on 49 degrees latitude. When the lines of latitude are based on the angle at which you see Polaris, that tells you there's going to be some problems if Polaris is up there moving around. Now, 1 degree every 75 years doesn't sound like much, but when you put it onto a map, that's about 69 miles every 75 years. That's almost like a mile a year. I personally wouldn't want to base permanent boundary lines on something that continually changes. Do you think they're out there continually moving those borderlines? I don't think so. This message has been brought to you by the Flat Earth Institute of Science, with a shout out to our Flat Earth friends at jdecals.com.